Right, so the problem's name is bear and species. So let us see what the problem states. Bearland can be represented as a square grid that consists of n rows and n columns. So there is a 2D grid of n rows and n columns. Two cells are called adjacent if they share a side, and each input cell is described by one character. So there are characters also. Let us see what the character denotes. So a dot is an empty cell. A B, G or P is a cell inhabited by bears of brown, grizzly and polar bears respectively. So a B will indicate that the cell is inhabited by a brown bear, and same goes for G and P, G for grizzly and P for polar. And a question mark is a cell inhabited by bears of one of the species, but we don't know which one it is. Okay, so these were the characters. So now let us look at the problem. So grizzly bears are the most aggressive species. If a cell is inhabited by a grizzly bear, then all the adjacent cells should be empty, because otherwise there would be fights. So when there is a grizzly bear in some cell, then all the adjacent cells must be empty, else there will be a fight. And brown and polar bears are a bit calmer, so they would not fight if in the surrounding or in the adjacent cells they have the bears of same species. So if in a cell, let's suppose there is a brown bear, then in the surrounding or in the adjacent cells it can be either empty or it must have the bear of same breed. That is, if a brown bear is there, then in the adjacent cells there must be brown, or if a polar bear is in one cell, then in all the adjacent cells there must be polar bear only, in order to avoid the fight. So X denotes the number of question marks. Since each question mark represents one of the species, there are 3x ways. Alright, this is clear. Now what we have to find is the number of ways such that there are no fight between the bear. So we'll be given a 2D grid basically with some characters, and we need to return the number of ways in which there will be no fight, and the answer would be long, so we have to return modulo. Okay, alright, so let us look at some of the examples. So here is the first example. The input size is 3, so it's a 3 cross 3 2D matrix that you can see. Just a second, this is the 2D 3 cross 3 grid, and in how many ways there can be no fight. You can see that there is a brown bear in here, so all the adjacents must be a brown bear only. So there is only one way in which there can be no fight, so the answer to this example must be 1. Yeah, that is, it is 1. Let us look at one more example. So the input size is 2, so it's a 2 cross 2 grid. What should be the answer of this case? The answer should be 0. Why? Because we can see that there are two grizzly bears together, and it was given in the problem that two grizzly bears can't be together, else there would be a fight. So the answer to this test case should be 0. Yeah, 0. So let us see how we are going to solve this problem. Alright, for solving this problem, let us see these 4 examples, and these 4 examples will represent the type of cases that we will be encountering while solving this problem. So let us look at the first example first. So I'll be calling this portion as island and this remaining dots as water, because what we are really concerned about is the island only, because in this island I'll be taking the question marks and the bears, that is the occupied part basically. So let us look at the first example. In how many ways can we avoid this fight? The real question is there any way? The answer is no. The answer to this case would be 0. Why? Because there is a grizzly bear, and as we know that a grizzly bear do not like to have neighbors. So this question mark represents that there must be some bear that we don't know, but since we know that our island has a grizzly bear, so in this case a grizzly bear will not like to have neighbors. So the answer to this test case should be 0. So I'll be writing the equivalent conditions or logic on the right side. Okay, so I have written this. If our island has a grizzly bear, that is island dot has g, if it is true, and the island size is not equals to 1. The island size here is 4. So if such is the case, then we have to return 0 because grizzly bear do not like to have neighbors. So now let us look at the second example. So in how many ways can we avoid fight in second example? The answer is 0. Why? Because this cell is also occupied and this is also occupied. Okay, so if we have a brown bear here, then according to the instructions given in the question, the brown bear only has the neighbors of same breed. So here there must be a brown and a brown bear, and same instruction goes for polar bear. Polar bear also likes to have the bears of the same breed, but here there will be a conflict because the neighbor of B will be B and the neighbor of P will be P. So here is the conflict. So the answer will be 0 in this case also. So for this particular case, let me write the logic on the right side. So here it is. If my island has both a brown bear and a polar bear, then I will be returning 0. And this was my island. So now let us look at the third example. So there is only one question mark. The island size is 1. So in how many ways can I avoid fight? So in this case, the answer will be 3. Why? Because this particular cell, I can fill it either with grizzly bear or polar bear or a brown bear, because the island size is only 1. So that means on the outside everything is water, or you can say that every cell is empty. Okay, so for this particular test case, let me write the logic. So here is the logic. If my island size is equals to 1 and my island does not have, this is a not sign, does not have any polar bear or a grizzly bear or a brown bear, then my answer will be simply answer multiplied by 3. Let us suppose the initial value of answer is 1. So in this case, my answer will become 3. Okay, so let us look at the last example now. So in how many ways in this grid we can avoid fight? The answer is 2. Why? Because the island size is more than 1. That simply means it isn't the case for grizzly bear, and the remaining 2 we can fill with any of the one polar bear. So it can be filled in 2 ways. So here is the condition. If my island size is greater than 1 and island does not have any brown bear or a polar bear, then my answer will be simply answer multiplied by 2, and initially let's suppose the value of answer was 1, so we'll be returning 2. So let us look at one more example and then we'll code out the solution. Alright, so let us look at this example also, and what is different in this example, why I took it separately, because it has multiple island. Of course, we will not be always given a test case where there will be only one island. So there are 2 islands, one is this and one is this island. What is island? That is connected component of occupied cells. So this is the connected component. There are 2 connected components of filled cells. So these are the 2. What for multiple island we have to maintain a list, that is an array list. This will be the array list. Okay, so for the first island, its size is 1 and it has a polar bear. No, so I'll make it false. Does it have a brown bear? No. Does it has a grizzly bear? That is has G. No. So this is for my first island, that is this. Now similarly I have to write for the second island. So its size is 3, 1, 2, 3. Does it has any polar bear? No, false. It has a brown bear? No, false. It has a grizzly bear? No, false. So now we have to calculate the answer. So I will take this object out of this list one by one, and there can be one question in your mind that why I took objects. The reason is you cannot store multiple information in one variable. I have to store these 4 information about an island in something. So that's why I considered making an object. So this whole will be an object that I am calling an island. and I'll be storing all the objects in a list, and I'll take it out one by one and calculate my answer. So here is the first that I'll be considering. So its size is 1 and it does not have any polar bear, brown bear or grizzly bear. So let us see which condition it is satisfying from the right side. So according to me, the third condition is getting satisfied. Its size is 1 and it does not have any polar bear or brown bear or grizzly bear. So the result will be result into 3. So let's suppose I'll initialize my result from 1. So currently my result will be 1 into 3, that is 3. And I am done with this object, so I will cut it out. Okay, so now I will take the second object. So its size is 3 and it does not has any of the bears. So which condition is it satisfying? I think it is satisfying the last condition, that is the island size is greater than 1 and it does not has any polar bear or a brown bear. So the result will be simple, result into 2. So my current result is 3. So the final result will be 3 into 2, that is 6. So the answer to this problem will be 6. So in this manner we will be solving this problem, and things will get more clear when we'll code it out. So let's quickly code it now. Okay, so let's first quickly create a class for our island. And inside that we were having 4 information. First is, let's suppose, the size of the island. Grizzly bear. So these were the 4 variables that we were having. Now let's just quickly make the constructor. The name of class will start from a capital letter, and we have to make the constructor. So initially I'll assign the size as 0 and this as false. Similarly goes for the other variables also. Alright, okay, so let's write main now. I'll first have to assign the scanner class. Let's say T for the number of test cases. Okay, after that while T minus minus is greater than 0. So enter n will be the size of grid. Right after that character grid, and its size will be n cross n only, and then a boolean grid for checking that we don't visit the same cell again and again. Okay, let's call it visited. After this it will be of boolean, and size will be same n cross n, and after this the loop I equal 0, I must be less than n, I plus plus. Inside this taking input, and write this, the second loop equal 0, must be less than n, j plus plus. So inside this I'll be simply assigning the values of each cell. So that will be put line character at j, and visited, initially assigning every cell as false, that it is not visited. Okay, so after this two loops, we have to print our answer, and the helper function that I will be writing is, let's suppose, get result, and what we have to pass it, a grid, visited 2D boolean array, and the size of our grid. So yeah, this should print our answer. Now let's quickly code the helper function. Okay, so let's write our get result function. So private static long, the answer can be quite big, so taking long, get result, and what we passed was a character grid and a boolean 2D grid that is visited, and an integer n for the size. Okay, so inside that I'll be taking a list that will store our objects for multiple island case. So I'll be calling it island list. That is new array list. Okay, now inside that for inside this we will check if the current element is not water, if the current is not equals to a dot or a water, or and it must also not be visited. So if such is the case, then we are interested in exploring the island. So for exploring, first we have to define an object of island class. This will do it, and then we'll be calling dfs. It is basically a function that will help in exploring the island. Okay, so what we have to pass it, grid, the visited boolean 2D array, input size, current location I comma j, and of course our object. So after coming out of this function, if my island dot size is greater than 1, then I will be putting this particular object in my list. So island list dot add island. So up till this we are clear, and after coming out of this two for loops, then we have to check that our logical function. So let me write long result. Initially we'll be initializing it as 1. So after that there will be the condition that I explained earlier, so that I'll copy from there, no need of writing it again and again. So this is what I copied. This I'll be iterating over the list, that is this, and these are the 4 conditions that I already explained in the explanation part, and we'll be returning results. So we are just only left with one function, that is dfs. So let us write that quickly. Okay, so here is private static void as dfs. Its return type is void because it's just for iterating through the 2D matrix. And what we pass, we have to write here, this boolean visited, and the size, the current location, and ij, and the object. Okay, so these were the things, And first of all we have to write the exit condition, because it will be a recursive function, so you have to write the exit condition first so that it does not go out of the bound. So if suppose my I becomes less than 0 at any point of time, or my I becomes greater than the input size, similar condition goes for my J. At any point of time I would not like to go out of bounds. So these were the conditions. If any one, so sorry, here it will be or, if even any one of the following occurs, then we have to return. So this is very much important, the exit condition. Also I don't want to visit one cell again and again, so that is why the visited 2D, I have taken 2D array. So if visited is true for the current cell, then I will not like to visit it again, so I will return. And also the third condition, if suppose my current element of the grid is water, so that is a dot or an empty cell, what you can say, then I'm also not interested to explore that, so I'll return. So these are the three exit conditions that our DFS function will have. And after that you will simply check if suppose the current element is a grizzly bear, then what you will do, you will simply mark island.hasg as true, such that we can know after getting out of this function that yes, this island contains a grizzly bear. Same goes for the other bears also. So I'm gonna copy this and just slight modifications, has b, then has b will be true. If it is equals to p, then has p will be true. And after checking we will mark the current grid as true, so that we know that it is visited. So this will be done. And after this, the 4 recursive calls, we have to write this also, that is we have to increment the size. Of course, once we explore one element, we have to increment the size such that we know the size of island at last. And after that, the DFS calls that it is visited, and so similar 4 calls will be made for the adjacent elements, this, and just the coordinates I will change, one for left, right, up and down. So here I write I plus 1, here it will be for j minus 1, j plus 1. So this it's a very famous algorithm also, just like this, that is called as the flood fill algorithm. If you are interested, you can learn more about that. So yeah, this was the whole solution, and quite a lot of lines that I coded, but I have explained the logic part and I think it's not that tough to understand. So let's just quickly run this. So let's run this for this custom input. Oops, compilation error. What is it? Let us see. Oh, here it must be private. Hope we don't have any other errors. Here too it will be next, because we are taking string input. So let's run now. Okay, the correct output. Let's submit it now. All right, correct submission. So that was the problem.